In example 6 from section 9.4, we are told the price in dollars of a stereo system is given by the function p of x equals 1,000 over x squared plus 1,000. We are further told that x represents the demand for the product. So this means how many of the items, when they say demand, they are talking about that x is how many items will be sold. Question A says find the marginal revenue function. First of all, marginal tells me I need a derivative, but when I look further, I see revenue. And when I go back to the original wording of the question, my function is about price. So we don't actually have a revenue function right now. Let's think about what revenue is. Revenue is all the money you bring in for selling your product. So if you sold 30 products at $10 a piece, you would take 30 times 10 and have a total revenue of $300. If you sold 25 products at $2 a piece, then you would take 25 times 2 for your revenue of $50. So revenue is found by taking price times X, your number of items sold. So the basic formula for revenue is P, standing for price, times X. In our problem, we are told that P is 1,000 over X squared plus 1,000. So to create our revenue function, the first thing we are going to do is take our P, which is 1,000 over X squared plus 1,000. We're going to take the whole function times X. If I do that, I'm going to get 1,000x over x squared plus 1,000x. The first term, however, simplifies to be 1,000 over x plus 1,000x. Now, before we can do the derivative of this function, we need to rewrite it so that the variable is in the numerator. This will be our last step before we actually do the derivative. So, final form for us for revenue is 1,000. Now, this is x to the first in the denominator. If I move it to the numerator, it becomes negative. So, 1,000x to the negative 1 plus 1,000x. So now we actually know what revenue function is. We want the derivative of this because we want the marginal revenue function. So marginal revenue, if we drop the negative 1, take it times 1,000, we're going to have negative 1,000 x to the negative 1 minus 1 is negative 2. Plus, on the second term, we're going to keep our coefficient and take it times the original power, which is 1. That just gives us 1,000. If we go ahead and just do the rule so you can see it, the original power was 1. 1 minus 1 gives us x to the 0. But remember, anything to the 0 power equals 1. So our marginal revenue function will be negative 1,000 x to the negative 2 plus 1,000. We are going to need to use this formula in the second part, so I'm going to rewrite it as a positive power. That makes it much easier to work with. So it will be negative 1,000. We put it back over x squared plus 1,000. For part B on number 6, we are asked to find the marginal revenue at a demand level of 10 stereos, and then we are asked to interpret the result. So there's 2 questions in here. First is to find marginal revenue at 10 stereos. So my number of items is 10, and we need to put that into the marginal revenue function. So we're going to be doing R prime of 10. Putting 10 in, we will have negative 1,000 over 10 squared plus 1,000. So we will get negative 1,000 over 100 plus 1,000. Well, that gives us negative 10 plus 1,000, which equals 990. Now, this is revenue, so this is dollars. That's the answer to the first question. The marginal revenue is $990. For the interpret part, first thing you do is look to see whether your answer is positive or negative. Our answer is positive. Because it's positive, that's telling me that the revenue is increasing. So I'm going to start out by saying revenue. Now notice I do not write the word marginal here. Marginal is there to tell you to use the derivative, but when you are describing what happens, you are talking about what happens to the total revenue. So revenue increases by how much? The number we got, $990. When sales change from 10 to 11 stereos. This was about stereos. So the positive tells us it's increasing. The number we got tells us how many dollars that was. And you are always going from the number that you plugged in to the next number. So that's why I said from 10 to 11. On example 7, we are told the total cost in dollars of manufacturing X guitars, so the X is how many guitars, is given by the function C of X equals 100 plus 100X plus 0.25 X squared. Question A says to find the average cost function. When you are looking for an average of something in mathematics, we represent that by putting a bar over the name of the item. So for us to represent average cost, we are going to write the name C of X, but we're going to put a bar over the name C. That always represents average in math. If you think about how you find an average, you take your total number of items and divide by how many items there were. So to find average cost, we need to take our total cost, which is this function we were given, 100 plus 100x plus 0.25 x squared, and divide it by how many items, which is being represented by x. So we are going to divide that by x. Just to help you see this a little bit better, that's the same as having 100 over x plus 100x over x plus 0.25 x squared over x. So the first term does not simplify. It will stay 100 over x. The second term simplifies to be just 100, and the third term simplifies to be 0.25 x to the first. So this now is our average cost function. And that's all they ask us to do on A, is just find the function. So we are done with part A. Question B says, find the instantaneous rate of change of average cost with respect to the number of guitars produced at any level of production. So this is a lot of big words to tell you something actually pretty basic. Remember, instantaneous rate of change, we said, was always going to be wording to find a derivative. So we want to do the derivative of average cost of C bar. That's what that's asking us to find. The part that says with respect to the number of guitars produced at any level of production means find the formula. They want just a general formula with a variable in it for the derivative of average cost. Before we can actually do that, though, we need to take our average cost function and rewrite it so that the first term has the variable in the numerator. In doing that, it will become 100x to the negative 1 plus 100 plus 0.25x. So that's our original average cost function, just rewritten so that we can use our derivative rules. So now we're going to do the derivative of this thing, which means we still have C bar, but now we got to put a prime on it because we're going to do the derivative of it. This equals, on that first term, drop negative 1 times 100, you'll get negative 100 x to the negative 1 minus 1 gives me negative 2. The derivative of 100 is 0. And then the derivative of 0.25x. The derivative of x is just x to the 0. Remember, it's 1. So we get 0.25 as our final answer on the last term. So now we know our derivative for the average cost function. Question C says, find the level of production at which this rate of change equals 0. Well, rate of change is another way of talking about a derivative. So they're saying take the derivative that you just found and find where it equals 0. So we're going to set C bar prime equal to 0. So we're going to do 0 equals negative 100 x to the negative 2 plus 0.25. I'm going to move the first term to the other side so it'll become positive. And we will now have positive 100x to the negative 2 equals 0.25. What's going to help you see how to solve this is to take that term on the left side and give it a positive exponent. So we're going to rewrite that as 100 over x squared equals 0.25. Now, how would you solve that equation for the x? Well, first of all, you've got to get it out of the denominator. So we're going to take both sides times the x squared, which will now give us 100 equals 0.25 x squared. Remember, our goal is to solve for x. So we're going to divide both sides by 0.25. And we now get 400 equals x squared. If you take the square root of both sides, you get x equals plus or minus 20 if you do the correct mathematics. But remember that x stands for how many of something. So we can't use the negative version of this. So our final answer here is that x equals 20. On part D, we are asked to use the answer from part C, so our x equals 20, to find the instantaneous rate of change of cost. So this whole thing is telling me to find C prime of 20. Instantaneous rate of change tells me derivative. What are we doing the derivative of? Cost, the original cost function. So that's question 1. And the average cost. So the blue line, the average cost, means that we want to find C bar of 20. So that's what our directions are asking for us to do. Up to this point, we have not found C prime yet. So for C prime, we need to go back to the original problem. Let's find C of x first. Rewrite it because it's off screen here. C of x is 100 plus 100x plus 0.25x squared. We need the derivative of that. So C prime of x will be, the derivative of 100 is 0. The derivative of 100x is going to just be 100 plus, take 2 times 0.25, you're going to get 0.5 x to the first now. Then it says we need to do C prime of 20. So we are going to take that C prime that we just found and put 20 into it. So we will have 100 plus 0.5 times 20. Half of 20 is 10. So we get 110. The other thing that we are asked to do here is to do C bar of 20. So let's go back. We don't have C bar on screen either. So our original C bar was 100 over x plus 100 plus 0.25x. That was what we found C bar to be way back in question A. We are supposed to put 20 in there. So we're going to put 20 in. We're going to get 100 over 20 plus 100 plus 0.25 times 20. 100 over 20 is 5 plus 100 plus 0.25 of 20, 1/4 of 20 is 5. So what do we get? 110. And what did they want us to notice? The answers are the same.